In this episode of Hot Hardware's 2.5 Geeks, we have monster CPUs from the desktop to the data center, and the best of CES will be recapped next. Welcome back, ladies and gentlemen, brothers and sisters, friends and enemies. Good to see you. It's been a while. Dave Altavilla here for Hot Hardware and the 2.5 Geeks live stream. We've been busy. The boys are here. Marco's here. Chris is here. How you doing, fellas?
Doing good. Can't complain.
Realize I'm in Marco's spot. Let me fix that real quick. And
no. Actually, hold on. You did the monster articles. You take that top spot.
All right.
Oh, wow.
All right.
Nice. He did do some heavy lifting, I must admit.
Yeah.
Heavy lifting on some big old chips, let me tell you. Which we will get to in a little bit. But boy, it's been a few weeks, and sorry we've left you hanging here a little bit, folks. But work had to get done, and CES and the insanity that is Las Vegas got done, and we had holidays, I think.
Something like that.
Something like that. And but anyways, it's good to be back. It's good to be back on the interwebs here with you folks, and lots of interesting stuff still going on in the lab. We have launches afoot in the mobile space, as folks have probably heard rumblings of. We have new CPUs waiting in the wings. We have GPUs out there. We have laptop hardware coming. I mean, it's all over the place, right?
Workstation,
everywhere. Don't give away too much.
Yeah, I know. Well, yes, and some of it's on NDA, so I won't give away too much. I'm just speaking in generals. It's almost like the pronouns of technology.
There you go.
Or something. Well, anyways, So what's new and exciting for you? Let's start with Chris. What's new and exciting for you these days in the labs? I think you've got a monstrous thread shredding, ripping thing in there, don't you?
Yeah, so I've got the Dell Precision System with a thread ripper, which I was working on and then got interrupted to do the Sapphire Rapids review, which is, let's see, behind me here. So the bottom one is Sapphire Rapids system. The top one is the Genoa system from AMD. Did not test them on top of each other like that. I kept them separate and all that. But for the stream, I decided to bring them both in to accompany me on camera. But yes, I also have the workstation coming from Dell, and I think I've got another laptop system coming after that. So plenty to keep busy.
A couple of 2U servers back there. Fun. Yep. Screaming, I bet. Lots of
when they're on, yes.
Yeah, there's a reason
I grabbed some noise canceling.
Yeah, no, we wouldn't subject the viewers to that. And
but the
and
workstation though is surprisingly quiet. A lot of times workstations can get pretty noisy, but this one does pretty well.
And it's a Dell Precision that you have coming.
Yes,
with the rippinest threads on board. Cool.
Yeah.
We'll wait with bated breath for that, young Chris. And he is young comparatively. Marco, what do you got going
comparatively?
I have two embargoed things that I can't say that are related to, well, they're on the way, related to what you said. I have the NUC 12 Enthusiast that I'm finally getting to, and I have to say, might be my favorite NUC yet. This is the one that has the mobile ARC graphics built in, and it is surprisingly good. Benchmarks are done. It looks phenomenal considering the size. Hopefully I can have that done in the next couple of days. And the embargoed stuff, unfortunately, can't tell you about, but it's definitely, if you're into mobile gaming, you're going to be
excited. Here, you'll like it.
Yeah, exactly. So some cool stuff coming.
Cool. Wow. So integrated ARC graphics on that little NUC, huh?
A770M. I mean, it's not under embargo. Like, I'm really surprised. So I think the personal circumstances that made me delay this really helped the product, because between the firmware updates and the latest ARC drivers, this little NUC basically competes with like a desktop system with an RTX 2080 in it. or like a 3060,
wow.
not a 3050-ish class,
Yeah.
depending on the workload. But like you can totally game on it. It's just a little bigger than the Hades Canyon NUC, way smaller than the Extreme NUCs. And it's a cool little rig. I dig it. So hopefully I can turn that quickly, because it's really a nice system.
Cool. Very cool. We'll wait with bated breath for that one too.
Yep.
Yeah. And I have things that well, I can actually show you.
Do it.
But I can't say much more about it. I can just show you. So this would be the OnePlus 11 5G.
So the 12.
What's that? What?
So the OnePlus 11. So I said the 12.
Oh yeah. Okay. Oh, sorry. I'm a little slow in the uptake, especially with the dad jokes. Yeah, no. So cool phone, as you can see, really serious camera array in the back. OnePlus outdid themselves on this one. Can't talk too much more about it. I can just show you it. Can't even have the screen on. But yeah, this is the what green do they call that? I think they call that the eternal green or something like that, and it's really nice metallic green. Really just a beautiful phone. I am looking forward to kicking the tires a little bit more on it. We got Ryan also working on it, and yeah, lots of good stuff. And we're going to be getting together with the folks at Samsung for Unpacked shortly as well, as you know. So mobile scene is kicking into gear. I'm also playing around with Intel Unison, which is the technology that integrates cell phones with laptops, or a new technology. I think it's a little bit slicker than Windows Link to Phone, or whatever it is they call it, Phone Link. Yeah, I think it is. It's a little bit more refined than that.
Yeah, I've tried using the Windows Phone Link and ultimately just had to stop using it because I'd have weird consistency with the Bluetooth connection and other issues. So I really want to see it work.
Yeah.
But I haven't seen it work yet.
It's getting better. I use Phone Link all the time, or Link to Phone, whatever they want to call it. And oh wow, dude, you just took a sip from that, and we totally heard the sip. Are you on the right mic, I wonder?
Oh yeah, you sure that wasn't the train going by Chris's mic that you heard?
No, that was your coffee. Actually, tap your mic, because it does seem a bit airier than normal. No, that's
okay. We're getting it.
All right.
Yeah, we're getting it. Okay. Man, that sip. You're a sipping boy.
I've got my local Kentucky bourbon here.
Oh, he's on fire tonight.
So
he's drinking the firewater. Well, I've got the Voodoo Ranger IPA. This is a new Belgium IPA. Voodoo Ranger. There he is right there. Ranging some voodoo. That's him.
It's a good one.
And yeah, it's a good one. And yeah, so anyways, I do think Intel Unison is something special, and we're going to be checking it out a little bit more. We may even have some Intel execs on to talk about it in the days ahead, so stick around there. But let's move on to the main event, shall we?
Yes.
Okay. So let's talk. What do you guys want to talk first? You want to talk data center? You want to talk desktop, big iron beasts, or what?
Yeah, let's do data center, because that stuff's wild.
Data center. All right, let's drop this baby in the chat, and we will talk about AMD Genoa. Like the salami
right there.
I hate when they say Genoa, because it's not Genoa, it's Genoa. Salami. Come on. AMD 4th Gen Epyc 9004 series launched. Genoa tested in a data center benchmark gauntlet by the Chris Topher, who was with us here today, the guy right there.
Yes.
And boy, look at that slab of silicon. That would be, what's that?
It's a huge chip. Well, many chips. So
yes. Chiplet.
Yeah, so like the Ryzen desktop chips, they've gone with a chiplet design on this. So what you have here, if I'll use the mouse to point, so there's going to be 12 little core complex dies around the outside, well, up to 12. And then you have your IO die in the center that kind of handles all the non-core stuff. And so with 8 cores per little chiplet here, that totals up to 96 cores potentially on a server platform, which is frankly just insane. But it was certainly a lot of fun to test. I'm just going to pop this here. So I do have it in hand. If I can get the focus, let me see. There we go.
Canon finally comes around for you.
Yeah, so this is actually the 64 core chip, because the 96 core pair is in the server behind me. But yeah, so it's a dual socket system, so you actually get two of these going. Which way? There we go. Two of these in the system at once. So it's not just up to 96 cores, it's up to help me with the math here.
A lot of freaking cores is what it is.
192, and then
192.
multiply that by 2 because it's got the
Right.
SMT, and
Right.
384 threads of just insane compute power.
Correct.
Potentially.
That's awesome.
So very, very fun systems to play with, and a lot of just general compute performance. So something I talk about in this review and the Intel Sapphire Rapids, now Xeon Scalable review, is really the different strategies that AMD and Intel are bringing to the data center. It's not as much of a just head-to-head battle as it has been in the past, because we're seeing different things come in. So AMD is sticking more to the traditional approach of going with general compute, brute force, throw a ton of cores, throw a ton of threads, high frequencies at the problem. And it does great for a lot of workloads. Whereas Intel has kind of stepped away from that brute force general compute approach. I mean, they still have some strong cores, and we'll get to that discussion in a bit, I think. But they've started incorporating more purpose-built accelerators, particularly things like AI workloads, and anything with a ton of vectorization kind of math, and really give specific uploads to specific problems that is kind of independent of the actual cores. So in a lot of ways, as we'll get to the Intel side, it makes that camp a bit more difficult to evaluate for your needs. And it's very much worth doing the research. But if I can pull up some benchmarks here just to show, actually, I'll go into the Intel review to see them side by side.
Yeah, just jumping in. It's so we've got a 14% IPC uplift per core in Genoa, plus more cores, so 96 of them, and some enhancements to some of the cast structures, and so a significant lift in performance, but brute force, as you noted, versus what Intel is doing, which is, they've scaled some cores up as well. 60 cores, I think, they're topping out at these days.
60, yeah.
Yeah, but they go discrete accelerators on chip, accelerators on package accelerators, are in silicon, and attack various cloud workloads with that approach versus more cores, theoretically freeing up cores to do work.
So real quick, I'm going to bring this in. So this is just showing the AMD camp from the AMD Genoa review. So the ones I want to point out here are the 9554 and the 7773X, which is the prior gen Milan X processor. These are both 64 core chips.
3D cache on that.
Yeah, so there is 3D cache on the Milan X processor, and there will be a 3D cache version of Genoa coming along as well. But we're seeing much more than a 14% uplift. And this is core mark. This is very quick and dirty compute performance. But even with 7-zip and other, more just quick CPU workloads, I think there's definitely more going on than just the IPC uplift. They've pushed clocks. They've pushed power in particular. So one thing I guess I maybe feel I've glossed over in these reviews is the TDP of these chips on the AMD camp is pushed up to 400 watts per socket, which is an insane amount of power. Intel's not far behind. They're pushing 350 watts. And I know a lot of people have kind of been concerned about that power output, especially when you're looking at rack density, and then the power delivery mechanisms you have to get into the rack. It seems like you're maybe leaving some power potential on the floor, because you literally can't power a rack full of these high-end 400 watt CPU per socket systems. But it does allow a lot of densification still of the data center. You can put, networking equipment and other stuff in those slots in the rack that may have been in a separate rack before. So even though the power delivery coming in, may see limited, there are still benefits to that approach. And a lot of the data centers are saying, yeah, we do have the cooling technology now to handle these kinds of thermals and power. You can get higher power levels pushed into a rack as well. But it will take some upgrades for a lot of data centers for sure.
But you're talking significantly higher core density per square inch. And so, therefore the benefits in terms of real estate. Power delivery is a different story. Let's go back to that slide real quick, Chris, because that model numbering, if you wouldn't mind putting the bar graph you had up that showed the generations. Yep. The model numbering is probably confusing for some folks. So on top, what do we got? The 96 core?
So the 96 core is up top. That's the 9654.
Right.
I think actually on the prior slide, I have the breakout of how AMD is doing their naming scheme. Then the 9374F is actually a 32 core part, which is nipping at the heels of the 64 core Milan X chip in this case. In some cases, it even surpasses that. So you're seeing basically a 2x uplift core for core in that particular comparison.
So 32 core versus
cases.
64 on the bottom. Okay. Yep.
Right. So maybe I should go back through here and add those core counts in just to make it clearer for everyone. But
and the 9554 is a 64 core.
Yep. So 32
Zen 4 Genoa, baby.
Yep. 64 and then 96 at the top. And I will say with the 96 cores, you're not going to get perfect scaling out of that, because the frequencies have to drop just a little bit. And also a lot of workloads simply can't scale to 384 threads when you have, two of these processors in the system as I'm testing them. So this is, two of the 96 core chip, two of the 64 core chip, two of the 32 core chip. So if you wanted to run a traditional Cinebench, for example, Cinebench tops out at 256 threads. It does not scale to 384. And yes, so as Steve points out, the F is a frequency optimized SKU. Let me take a moment to hop back to the slide where they show the naming, because it is worth understanding how they're approaching it. They're, especially with when they have a new numbering system versus what they were using with Milan and prior generations. So I think I have that here.
Yeah. Marco, what are you thinking about this, baby?
I'm thinking about how the data center market is changing and how the workloads are sort of evolving as we move more and more stuff into the cloud. So I'm wondering how this all shakes out long term. With obviously you're going to get massive scaling on a per core basis with AMD, because they're stuffing more high performance cores in their chips and ultimately into the servers, whereas Intel upped the core count as best they could with the process deficit, but with the accelerators, those cores are freed up to do other things. So it's going to be interesting to see what direction people go. I think it's going to matter greatly depending on the size of the organization and whether or not, obviously, Intel's accelerators are going to help in a particular application.
Right. Yeah. There's definitely a lot to figure out there. So basically here, we've got the Epyc naming convention up. You saw a similar one for AMD's mobile CPUs, but the numbers are different and mean different things from the mobile setup. But that's another discussion. So first is the product series. So this is the 9004 series, 4 being the generation of the architecture. Then the core count is in the second digit here. So 6 is their 84 to 96 core range. 5 is a 64 core, down to the 3 for the 32. Hopefully that's large enough for you to see at the bottom there. If not, come by the site. You can click on this and view it a little larger. And then they have their kind of performance within the stack number as the third digit. So within a given core count, where does AMD view the performance of this part? So the nice thing is, as I accidentally click into that, but so the nice thing with AMD from an evaluation perspective is you are largely just dealing with a per core scaling. Yes, there are things like they've implemented AVX 512 instructions and some specialized silicon like that, but it's really built into the cores and scales very well with their core counts for the most part. I mean, there are cases where you'll see in the review where the 64 core is outperforming the 96 core just by nature of the particular workload. And I think that 64 core CPU is probably the sweet spot right now. But if you have a workload that is really, really good with scaling across multi-core setups, then maybe the 96 core is more worthwhile for you. And I see Steve saying he's going to screenshot that. Don't screenshot it. Just go by the site. Go by the site, and you'll find it in all the detail there.
There you go.
But yeah, when we get to the discussion with Intel, it becomes a lot more challenging because of the accelerators. So one thing you kind of notice with AMD that goes against what I said is the AI workloads tend to actually prefer the lower core count parts. Not universally, but so let me bring this up here. For example, TensorFlow with GoogleNet or ResNet 50, the 32 core part is actually putting up the best numbers here. Part of that is because the latencies that you add by adding cores and more CCD on the chip is going to negatively impact certain workloads. So you can potentially see better results with a leaner chip. But when you get over to
and for folks that don't know TensorFlow, the workload, AI, neural networks, different models, whether it be for image recognition or image classification, things like that. So go ahead. I'm sorry, Chris.
Yeah. So yeah, looking at identifying what different objects are within image set as quick as you can, which is great for things like if you have a surveillance system and you need to classify what the surveillance camera is seeing on there, look for anomalous behavior. If you're in an industrial application and you have an assembly line going through and you're looking for defects, these kind of models are very, very important to have running optimally. As much as these chips can get into the thousands and tens of thousands of dollars, those kinds of workloads can easily save you that in a few hours of just getting it right.
Mission critical stuff. Yeah.
Right. So, as I was saying, for Sapphire Rapids on the Intel side, I'll start with the general compute. So you have some pretty good per core scaling. So here we have the 32 core Xeon, we have the 56 core Xeon, and the 60 core. So these two are very, very close. There's not a lot of difference here. You are getting slightly higher clocks with the 56 core. That's why it's not exactly a linear increase with core count. But we're seeing very similar things. 7-zip, the general performance. And what you'll notice in these general compute here, lower is better. This is software compilation with the Linux kernel. Is AMD just kind of is thrashing Intel with these general compute workloads. There's not really a nice way to say it because it's the reality here. Even the 32 core Genoa part is beating the 64 Xeon here as we look at the Jython test of the Decapo benchmark, which is so Jython is basically, it is Java, but you're using the Python syntax to write it. So people who are very familiar with writing Python can quickly adapt to writing Java code if they need to in a pinch. And so, I'm saying I flipped this result. So this one is actually a case where Intel is
that
doing
favors
better.
Intel, yeah.
But that is the opposite of, say, here with the building the Linux kernel, where you are getting the advantage on the AMD system. But most of these, as we go through, lower scores again for AMD.
Blender.
classic BMW render.
Yep.
We're seeing a lot of this where it's just, just faster on AMD a lot of the time. Especially when you're looking at PostgreSQL, which was actually, that one was kind of surprising to me because I thought there was a SQL or database oriented accelerator for Intel, but maybe I'm confusing that with something else.
I think there is a database accelerator for Intel. It just might not
It
be
may not come into
Postgre.
this particular workload because
Right.
you do need to explicitly write for the Intel accelerators. But I'm going to go ahead and flip to the next page where we can see more of the AI and other accelerated workloads. And so here we have SM Hasher, which the Y-hash hashing algorithm, it's not really cryptographically secure, but it's very, very fast. And so it sees a lot of application for that reason. And here, Intel is absolutely blowing away AMD with this hashing algorithm. And when you're, I've forgotten the particular applications where Y-hash is used, but it is used pretty extensively in web development and other things.
It's cryptographic processing. There's lots of different applications in the web, I'm sure, that use hashes. Crypto hashes. Yeah.
So it is pseudo random. Don't rely on it for mission critical, super secure stuff, but for good enough, it's great. Intel open image to noise, you may say, okay, it's an Intel benchmark. Of course, it's going to benefit Intel, but it is still using their accelerators for denoising, and this is used in I think it was used in like Moana and other Pixar films. And so part of it is when you do a path traced image as animations leading into, you get a very noisy image frame as a result, and you need to apply denoising to it to get a really intelligible image as a final result. So these kinds of denoising algorithms are very, very important also for gaming, but you're probably not gaming on a data center CPU. But you would be crunching frames either for visual effects in a traditional movie or an animated film. Very, very important. Here again, we're back into TensorFlow. So VGG16 does fare for AMD still. Not hugely, but it definitely leans that way. But for everything else, you see a very linear scaling with the Intel chips, and that's because these ones are running off the accelerator. And so even though this is a 32-core chip, it's right up there with everything else in the 56 to 64 core range. I think the 96 core struggles here because, again, when you're talking about the latencies and everything else, the AI workloads tend to fall off with that. But seeing it again with GoogleNet, it's just almost 2x here. ResNet 50, again, probably a 50% advantage. So when you can leverage that accelerator and make the most of it, it gets really good. Then you get down to neural magic, deep sparse. So deep sparse is taking AI models that are traditionally run on GPUs, and they're optimizing them by sparsifying the model, basically just taking down the little nodes that are actually relevant so that they can be run on a CPU much more efficiently. So up here where we're running TensorFlow, which is really built for GPUs, we're seeing, processes on the, sub 100 FPS. Here with the sparsification, 400 FPS, 600 FPS. And it is pushing, because it's CPU built, it is pushing the scale back in favor of AMD, where the traditional CPU cores are performing better with this particular model. But depending on what exactly you're doing in here, so this is the asynchronous model, and then down here we have synchronous, so this would be one after the other. You see, for Intel especially, that per core advantage really disappears, and your 32 cores putting up the best result. So it's
interesting stuff. Yeah.
Yeah, so it becomes very, very complicated to wholly evaluate these because one SKU can be so different from another in ways you don't expect. If you're really leaning on the accelerators, maybe you don't even need the cores. You can get the lowest core count Xeon CPU that has the accelerator you need, and you'll be just fine.
Yeah, I'm going to drop this into the chat, and you might want to bring that up because it occurs to me, and I think that's what for me what's a little concerning with Intel's vast menu offering here. If you scroll down the Xeon CPU Max series, with AMD, you've got core count and or clock speed, to consider. With Intel, it's core count, clock speed, accelerator.
Right.
There's a lot of different variants here.
Yeah, so break out your magnifying glass here. But yeah, so we have the SKUs for Intel going down the left side. You have core count in the second column. You have the frequencies here, the cache, the TDP, again, up to 350 watts. The scalability, everything on this particular slide is going to be up to a 2-socket scalability, which is the same as AMD. That is one place where Intel can have an advantage because you can actually get some up to 8-socket systems with Intel. But yeah, where it gets interesting is in this middle chunk where you're looking at the default number of accelerators that come with the chip. So there's another slide further up the article that shows, I don't even think it's all the accelerators, but there's a dozen or so different accelerators listed. This one here just shows a few DSA devices, QAT devices, etc. And not every Intel chip is going to have every accelerator or even the same count of accelerators. So these ones here might have one QAT device built in. As we go down here, where we find that 60 core 8490H, it actually has 4 of the accelerators built in. Now, I'm not exactly sure if I should be really running parallel workloads to hit 4 at a time or what exactly with the scaling there, because I certainly wasn't seeing 4x numbers out of this chip. So that's something more to explore there. But the other part of this is, yes, you have one QAT device out of the box, but say you have an application that can leverage 4. Intel has a program called On Demand, where with some licensing, you can just say, okay, I want to unlock 3 more accelerators. And you can license that out.
Yeah, and we should talk about a couple of acronyms there across the top. The accelerators names. QAT is Intel Quick Assist Technology. There's DLB, Deep Learning Boost. There's a couple others. There different types of accelerators for different types of workloads that you can unlock or remain locked depending on what you buy in the SKU. Firmware configurable, I guess one might say. But yeah, interesting stuff. And what I think we've talked about amongst the team, and Marco, I want to get your opinion on this too. We've talked about how, we're doing these benchmarks. You've got a general purpose workload benchmark, something like a blender that's just rendering, on CPU cores. And the more cores, the merrier for the most part. Maybe you get a clock speed boost in a lower core count part or something like that favors one general purpose benchmark over another. Generally speaking, scales pretty linearly, and you can see it, logically. You go to the accelerators, and that throws everything, to the wind, and now you get some performance that you didn't have before from a fewer core chip. So that's great, but now the question becomes, what can you do with those freed up resources, okay, while the accelerators are accelerating the workload, and so therefore not taxing general purpose cores. And so really that's kind of what we were kicking around amongst us on the team here, is that's kind of, if you think about Intel's value proposition, that's kind of core to it as well. Now, I don't know if, we'd have to think of some realistic scenarios where, a data center server that is doing, I don't know, let's say encryption acceleration and also video transcode, or encryption acceleration for, web hosting, whether it be SSL, processing for connections to a web server, and then some other workload, general purpose workload in the background. And because we've freed up those cores to do the general purpose work, by accelerating the crypto work with the accelerator, now what are we looking at? What's the compounded effect? And so there's a lot of nuance there, and it's difficult to kind of size up.
It's really difficult to evaluate those in some kind of controlled environment. It's something that maybe you can feel in the real world, but getting exact numbers for is just very, very challenging, especially when real world workloads are often so dynamic. You may have, say you're, selling capacity out to customers. They each have VMs running on the system. So you've got a few dozen different VMs on there. Some are active at different times, running different workloads at different times. And how exactly does that mix all come together? It's certainly a lot to evaluate, and something I definitely want to learn more and experiment with to find out. I also quickly want to get to this question before it disappears off my screen, about seeing performance and efficiency core designs creep into server CPUs. So with these Sapphire Rapids based Xeons, these are all performance cores, as Intel would call them, but they also have products coming out that are all efficiency cores, using basically the old Skylake architecture, as certain workloads don't really need the big muscle of the performance cores, but could scale out with a ton of efficiency cores and do just fine. So I don't know that I've seen in the roadmap that they're going to have any mixed
hybrid architecture.
Yeah, hybrid architecture. I'd have to go back and double check that, but certainly both core philosophies are going to find their way into products for Intel in the near future. Performance.
Marco, you've been quiet over there. You're chatting with the gallery.
All right. I'm sorry. I was trying to respond to all of the comments coming in the chat. Yeah, no, I'm enjoying the discussion, because this is a really difficult, generation to boil it down to any one thing. There's so much raw horsepower on AMD side and so much nuance on Intel side, that you really have to specifically know your workloads and which platform is going to benefit you the most. And then you have such a host of options on either platform. It's sort of dizzying this time around.
And then you have the real curveball that is the Xeon Max processors, which I haven't tested yet, that have 64 gigabytes of HBM memory stapled onto the chip. So you don't even need DDR RAM in the system to run it. You can just install the chip and go, which for web servers and other stuff, like, that's awesome. You can get insane density, which is a ton of cores. You could stick 8 in a server and not have any DIMM modules taking up space and do what you need to do.
On the downside, though, is you have no upgradability in terms of memory, and if your workload isn't memory bandwidth intensive, it's wasted. Like, again, there's so much nuance with all of them.
There is.
Yeah, it could be really good for some workloads. Yeah,
but you can also have it in systems with DIMMs, and you can either use it as a monolithic HBM and the DIMMs working together as one memory page pool, or you can tier them out. So yeah, priority goes to the HBM memory, but then if it spills over, it can go to the DIMMs, and then beyond there to CXL, and just keep adding on layers of memory depending on how quick you need it.
That'd be a hell of a RAM disk, James. Let me tell you.
Yes,
little HBM RAM disk. Yeah, why not? So, well, yeah, that's pretty cool stuff. I mean, I think what's interesting now is that we are seeing, and let's just take it up high level a little bit, maybe, and then we'll wrap this up because we got to move on. But what we're seeing now in the data center, in the cloud, is a very, what I would call open, sort of ecosystem to lots of different ways of addressing problem or addressing a workload, a processing workload. You can throw more cores at it. You can throw accelerators at it. You can throw ARM cores at it now. It's starting to get to the point where, it's kind of like, bring a core. What do you got? And, what's best for the job? You look at guys like Ampere and, some of these ARM core server processors that are kind of waiting in the wings and starting to chip away. You see them showing up in instances with Azure and whatnot. It's a fascinating time because it used to be that there was one way to do it. It was clock speed and cores, right? And now it's
it also is very interesting
ways.
for someone who is, maybe getting a VM from a provider and you're buying your virtual CPU cores. Well, what kind of core is it?
Right.
I mean, there can be vastly different performance for that core.
Right.
And actually, a comment that Steve threw in here. He meant to say Bergamo here, but we have the cloud versions of Genoa coming as well. That's actually a different core architecture. It's Zen 4C with smaller cores and reduced cache reportedly. Full details haven't been released. How does that affect performance? You can have up to 128 cores on those, but per core performance will likely be lower to some extent. So much stuff. It's going to be just insane. And, just a cool coincidence. The first magazine cover, where is it? Where one of my articles made the cover. Look at it. AMD's war with Intel. That was 20 years ago. And it's still apropos. That cover is 20 years old.
That blows me away that you have that. Oh, wow. Is that CPU Mag, dude?
CPU magazine, yeah.
Oh, wow. Marco and I used to do a little bit of writing for CPU Mag. And is that really 20 years old? Really?
2002.
Oh my God. That's so bad. How old were you in 2002, Chris?
No comment.
But dude, that may feel like you're a youngin', but that is goodness. Trust me.
I think I was high school.
Yeah. Oh, okay. Cool.
No, middle school. Sorry.
Oh, geez. All right. Stop. You're killing me, Smalls. All right. So I'll just drop this in real quick and then we got to move on. AMD also came out with, switching back to AMD, the MI300 accelerator, which is a pretty interesting device. Now you've got all kinds of conjoining of CPU and GPU in a chiplet design for machine learning. AMD unveils Monster Instinct MI300 hybrid CPU GPU AI accelerator, and Skynet smiles. Well, I mean, machine learning is and in the data center is a big burgeoning new frontier now, and I think what we're seeing not only for R&D effort from the major chip players like Intel and AMD for CPUs. We're also seeing an equal amount, I think, of resources and energy and R&D poured into AI and accelerating what we call artificial intelligence, or in a loose way, machine learning or intelligent machines that learn and adapt. And this is pretty interesting stuff for sure. So check that out when you get a minute.
I just want to say all these chiplet packages are just so cool looking to me. Whether it's here, I mean, technically the Sapphire Rapids chips are doing the same thing. They call them tiles, but I like seeing it all fit together. It's very satisfying to me.
Yeah, and then Intel Ponte Vecchio too does that. Yep. Go ahead, Marco.
That chip is wild to say. For me to take that, I was the first person to get a super high res photo of that chip. There was a really small group that got to handle that. And everyone gave up on taking pictures because we're in an environment where the lighting was wild. Everyone was getting crazy reflections. That took me like 20 minutes to get one that was sort of usable. And I happened to capture it at 50 megapixels. So I have a really high res shot of that chip if anybody wants it.
There you go. Maybe we should put it up on Hot Hardware.
Put it on.
Well, it's that pic, just not scaled.
Yeah. What's this, James? Curious if AI could give us a multi-purpose ASICs for compute tasks on the order of 500 times faster than we can do now.
Can I can mention something there?
That's
Dave
interesting.
Dave and I work with
I
a
wonder where he's
company.
going with that. Yeah.
Yeah, so Dave and I work with
That's
a
a great
company
question.
who uses AI as a major component of their design tools for chip design, and their goal is 1000x in 10 years, right? That's the stated goal is 1000x performance, 1000x, I forget what the other pillars are. But yeah, like eventually AI is going to allow the engineers to strictly focus on, being creative and architecture and all of the sort of grunt work that goes into designing and actually manufacturing a chip. The AI is going to handle it. So I'm going to bet yes, we are going to have that.
Yeah, that's a great question. I was gonna agree with. I certainly agree with that synopsis, Marco.
Now, the idea of multi-purpose ASICs, then you're kind of getting back into general compute territory a little bit.
No,
versus-
but I think what Marco was talking about is like I think
the performance uplift for sure.
Yeah, but with the crux of the question that James was asking was, can AI actually design chips such that we can get significantly better performance and more sophisticated chip design? And yeah, and Marco, you talked about this grunt work that the AI is doing now. It's doing floor planning where it's literally planning circuits out on silicon. And that that place and route, what they call place and route, is grunt work activity for a human engineer who could be doing more creative design work versus optimizing place and route. Soon we'll be feeding the AI the software it needs to run so it can design the circuits better.
I think
crazy.
I think the most interesting potential for that is to really get more stackable design, because as you add on layers, I'd imagine the complexity increases exponentially.
Cool
and
stuff.
You could really see some interesting stuff come out of that.
Yep.
Amen. All right, so we should probably move along. Are we going to get through to the best of CES, gentlemen?
We'll just turbo through that.
turbo that baby. Yeah. I'll drop it in. This was interesting stuff. We should talk about a couple of the highlights along the way for sure. Hot Hardware's Best of CES 2023. Marco and Chris were boots on the ground in Viva Scenic Las Vegas. And really for us, it's, the way we cull this list together is, just we asked the editors on the team, from all the CES announcements that you saw, Marco or Chris in person in Las Vegas, or that our news desk saw come over the wire that they reported on. What do you feel was the most exciting technology? Doesn't necessarily mean what we feel is going to be the best in the market that will, mop up the most, dollars, but what was the most innovative tech?
Right. CES is about the concepts and what we're going to see and what caught our interest.
Yeah, there you go. And so there you go. Intel 13th gen Raptor Lake mobile CPUs. We're excited to see those. We've seen what Raptor Lake can do on the desktop. Marco's got copious benchmarks on the desktop platform, but mobile should be exciting. Right. What are your thoughts there, Marco, before we move on real quick on that? I know you've got some opinions. I'm interested to see what the 28 watt, power envelope performance thin and light category does.
Yeah, I mean, so we may be able to show you how that all shakes out soon enough. I think, Intel's really been aggressive. If you look at how quickly we went from 12 to 13th gen, both mobile and desktop, it's been a really, semi-rapid development, and it's kind of changed the landscape on the desktop, right? A year and a half ago, 2 years ago, it was all AMD. Now, Raptor Lake S is the leader, right? You can nitpick a couple of tests where AMD pulls ahead, but if you're not factoring in power, right, that's where Intel's really lags behind. In terms of strictly performance, if you want no compromise perf, Intel is it right now, right? So Sapphire Raptor Lake S is a kick-ass part, so it's going to look really strong in terms of perf in the mobile space. The real question is power and battery life, and we'll be able to answer that soon enough. So, but I'm looking forward to it.
There you go. Chris, scroll on down to the next one, and Ryzen 9
I think a lot of people are
7950
excited about this.
X3D. Yeah, I'm kind of jonesing for it. I'm really I'm a little bit torn. Excuse me, between the 7950 X3D and maybe like a 13900K or KS. But yes, AMD rolled out multiple chips with 3D V-Cache strapped on board. This is the 7950 X3D. This is the one everybody wanted when the first 5800 X3D came out. And this is the 16-core jammy with copious V-Cache strapped onto only 8 cores, right? It's
onto
not
one
right.
of the
It's not
CCDs,
balanced,
which is
Yeah.
interesting. It's slightly lower clocks on that CCD that has the V-Cache, but the other CCD gets to have higher core clocks. So you can
A little bit of
kind of
best of both worlds.
a little bit. I mean, depending on
Yeah.
your workload and how it's hitting it. So very
Well,
interesting.
that was AMD's rationale, right? Throwing 3D V-Cache on both. Sure, they could have done it, but they wouldn't have achieved the clocks necessary to maintain that single thread leadership and max performance with multi-threaded workloads. But doing it this way, and they've worked with Microsoft on the schedulers, and you can, if you're running a game, clock speed on the CPU cores doesn't necessarily matter. It's going to get parked onto the CCD with the V-Cache, and you get that great game performance. But if you're running a workload where max frequency is going to help, it'll be on the other CCD. So it's going to be interesting to see how that shakes out when we actually test it with real world applications and stuff.
Seems a
Soon.
similar problem to the P versus E cores on the Intel side. So I'm sure there's some magic worked there.
Cool. Good stuff. Good job, AMD and Intel. And then NVIDIA, not to be overshadowed, stepped out with RTX 40 series mobile GPUs, which we are also getting very close to kicking the tires on. I think this is another sort of sleeper. What did you do, Marco? I missed it.
I was like, maybe we're going to be looking at it. I don't know.
Okay. I didn't know if you held something up or whatever, but
No.
excuse me. Yeah, no, this is another kind of sleeper, or not another sleeper. This is a sleeper. The other two weren't so sleepy. But I don't think a lot of folks are really expecting, because the RTX 40 series seemed so large and power hungry, even though it's really not. It's more power efficient on the desktop. This could play really well in notebooks, right?
Yeah, I mean, I have a demo. There's video on the YouTube channel. I don't think we actually stuck it up on the site anywhere, unless we embedded it in the coverage, that shows RTX 4080 mobile versus 3080 Ti outperforming 3080 Ti at a third of the power. Now, that was in Cyberpunk with DLSS, with frame generation enabled, but still, smoother, better frame rates at 1/3 the power. That's huge. So like if you want to play on battery, you turn on battery boost, maybe limit your frame rate, you're going to get much better battery life on 40 series than 30 series. And that could be a big deal for some mobile gamers.
Yeah.
Or just dealing with less heat to begin with.
Yep.
Yeah. And but I think you've got something waiting in the wings very, very soon on that, right, Marco? Maybe. Perhaps. You're not allowed to talk about that. I don't know.
No, we can't.
Okay.
I know nothing.
We know nothing, Schultz.
Nope.
All right. ThinkPhone by Motorola, a Lenovo ThinkPhone by Motorola. I'm really jonesing for this. I'm a phone guy. I love phones in general, and I love the ThinkPad styling. It is a daily driver of mine for a laptop. This combines the best of both worlds. You get that little textured, almost. What am I thinking of?
It's the aramid fiber back, but you're thinking the carbon fiber.
Carbon fiber. Thank you. Wasn't coming out of my elderly brain. Yeah, carbon fiber design. It is built with Qualcomm Snapdragon 8 Plus Gen 1, so a stout SoC. It's got a big beefy 5,000 milliamp hour battery, 65 watt charging. Pretty good stuff. Nice 144 hertz OLED display. Pretty high end phone. I'm eager to see what Lenovo and Motorola typically does well with camera. I want to see what the camera chops are like on this thing. The camera's pretty good outfit too. So, Chris, you're probably excited about this little fella.
I am. So before I went Nexus with Nexus Pixel. Wow. That's how long I've been into phones. But the Pixel 3a was my first Pixel. But before that, I was pretty much all Motorola. Going back to the Droid.
Yep.
The Droid X, and then the Droid Razor HD Max, and the Moto Plays and stuff. I really miss the carbon fiber style backing, the aramid fiber, as they say now. It's just grippable. It felt like you didn't need to use a case with the phone. And when I was there in Vegas, the representative there showing us the phone actually like dropped it from shoulder height and just casually dropped it on the ground, and it was fine. So seems like they've really taken durability to mind with this. And, if I don't have to use a case, I'm not going to. But with, these Pixels and Galaxy phones and everything else, it just feels so fragile that I don't dare go without a case. But if I don't have to, it's very, very tempting. And it still has all the awesome Moto actions built in, the chopper flashlight and everything else that I still miss to this day. Oh, you're muted, bro. Dave.
And he's still muted.
All right.
Oh, sorry. I'm back. So Alienware X16 M18. I thought that was pretty interesting stuff. I saw that live with you, Marco, in New York. Really sleek looking X16. That is it. Exploded. Innovative thermal solution there. We won't dive too much into it, but it's a sleek looking 16-inch laptop. There it is right there. New LED array, micro LED array in the back with all kinds of RGB goodness. There's the M18. That is a big old boat anchor beast machine. You can get it with 13th gen. You can get it with 13th gen with GeForce RTX 40 series. You can get an all AMD affair as well. That is a beastly looking machine. Fast displays too. I think there's a 144 hertz display option there. And then the other thing that was pretty cool in the land of laptops was the Yoga Book i9 dual screen. So here you're looking at Lenovo's, this was what we would call a splash product for sure. It is basically a clamshell that is built of two OLED displays. It has a detachable keyboard that slides up into different configurations. The demo really makes it click. It looks cumbersome here, I know, but it's not. It's really kind of slick. I know you guys saw this thing live. I'm not doing it enough justice. It's the demo really spoke volumes to me.
Yeah, you got to watch the video. There's a video of that on the channel as well. Definitely, Steve says he hasn't seen it. You have to see the video of it in action because Lenovo incorporated a number of really cool gestures to make it super easy to switch between these different modes. And if you don't want the big dual screen setup, it can function in typical clamshell mode. But if you want all that extra screen real estate, it's there and super easy to switch to. So this is a very cool product. Lenovo typically uses CES to show off some cool, futuristic stuff, and this year was no exception.
Yeah, I just got through dropping a link in the chat. Folks can check it out.
I think I got it here.
Oh, nice. Good job. Look at that. So now we get a little demo here. You can see there's some scrolling going on. Yes.
So just really quick, you can basically 5-finger press to get your web page to just waterfall, I think is the term they use, over to the other display. So you can kind of get that seamless experience between them, pop it right back. And then with the keyboard, obviously it clicks into the stand there and it's Bluetooth and all that, but you can also put it on the bottom display to use more like a traditional laptop in one of two positions. So you can either have it down close to you and the top half of that bottom display can give you some heads up widget type information, or you can slide the keyboard forward up towards the hinge and then the bottom part becomes a trackpad. And so there you can see it there. You can take notes on the right side. So you get some flexibility in how you use it. And it seems to work very, very fluidly, very intuitively. And if you don't want to use the Bluetooth keyboard at all, you can use an 8-finger gesture to just bring up a keyboard on the bottom display, a virtual keyboard. So
cool
lots
stuff.
of options.
Yeah, cool stuff for sure. And as you can see, the demo does speak volumes. I think for me, what's interesting about this, the most interesting about this, there's the virtual keyboard on the bottom display. Slide that down too, and you get some widgets. The software execution is what's key with this product. Yeah, you can have, a couple of nice, beautiful OLED displays and some great design chops, but if the software is clunky and doesn't service it well, you got a fancy looking whatever that gets in the way. That's a pretty cool, I think, execution from a software standpoint. Good stuff.
Yeah. So
good stuff.
Of course,
and then of course, yeah. Go ahead.
The 57-inch Odyssey Neo G9.
I'd take one of
mini
those.
LEDs.
Too big.
So I have to say, I don't like the super ultra wides. I prefer discrete monitors, but I have friends who absolutely love their super ultra wides. So if that's your thing, this will be an awesome monitor. I mean, that's a ton of screen real estate.
Yep. And that's kind of it. That kind of wraps it up. I mean, we saw a lot of different things. Sony's Leonardo controller for PS5, nice accessibility feature, AirJet, which is pretty cool. Fanless air cooling systems for laptops. Could be some interesting tech coming. Snapdragon satellite. I mean, really just good stuff. Snapdragon satellite allows satellite communications for phones in areas where you can't get a cell signal. Yeah, so that's kind of key. And then, Gen 5 SSDs.
12 gigabytes a second.
Tasty bandwidth. Gotta love that. And then that was a really cool, and we'll finish up here, the ProArt 3D Studio Book 16 3D display enabled Asus machine there. That was pretty wild stuff.
I so expected it to be a gimmick. I usually can't stand that kind of 3D stuff. But it actually, like, you get the actual sensation of depth reaching into the screen. It's something that no video, no photo can do justice. You just have to experience it.
Yeah.
So Asus had it. I know a couple other companies were implementing the technology as well. That's the one I saw. Very, very cool.
Yeah, I'll drop a link.
I'm such a nerd. That router is what I really want the most from that list.
Yeah, what is that? Like a Wi-Fi 7 or 6?
Wi-Fi 7 with multiple 10 gig ports. It's just a beast.
Yeah, and is that the one with the motorized antenna that move around?
No, that was MSI.
That was MSI. That's right.
Yeah.
So does it do the MSI one? Does it do beamforming? Like it actually optimizes and it's motorized?
Yeah, if you set up a priority product, because you can't, obviously, if you have multiple devices, it can't handle them all, but it will tune the beamforming by positioning the antennas perfectly.
Oh, I love that idea. What a great idea that is. I got to check that out. Good stuff. Hey, gentlemen, we work in a fun industry where there's all kinds of new toys to experience. And that's why we do what we do, right? New tech is exciting. Yeah. All right. And I'll just mention this real quick, and we got to wrap real quick here. The good folks at Lenovo sponsored a New Year, New Gear giveaway. We have 4 winners actually, for some great Lenovo prizes. We have a ThinkBook Plus 17-inch laptop, also with a dual screen laptop. It has a screen in the numpad location. Pretty cool. And then an IdeaPad 5i gaming Chromebook that has GeForce Now loaded on it, and I think it's a 3-month subscription there. And then a bunch of peripherals and lucky winners, and lots of people entered, thousands of people. And Kevin, Steve, Albert, and Lori, they won.
We've got Albert in the chat. Did we get
Albert's
his email?
in the chat. Oh, what's up, Albert? Did we get your email? Yes, I think we did. Albert won the what did Albert win? Let's see. Let's look. He's prize 3.
The headset.
Correct?
Yep.
Yes.
Don't give it to him. Don't give it to him.
The Legion S600 gaming station and Go wired speakerphone. Yeah. So Albert, that's coming your way, buddy. Thanks for joining us. Yeah, we're gonna get ship to information to Lenovo. They'll be shipping out the prizes directly to the winners. And Albert, welcome to the fold, my brother.
Congratulations.
Congratulations. Yes, we like giving stuff away. It's a good feeling, to give back. Yeah, 133K entries, Steve. You're right. That was a I mean, I don't think it's quite as it was quite as slim as Lotto, but it was a well participated in giveaway, so for sure. All right, well, we should probably wrap, gentlemen. You can find us on the web. Why don't you tell them where they can find us, Marco?
Oh, I got to do it on the spot. So obviously hothardware.com is
Yeah.
where all the good stuff is posted.
Never heard of it.
Just real quick, we also had the 13900KS full review and the 65-watt Ryzen 7000 series review. Too much to chat about here, but go by the site because those Ryzens are really the sleepers, and the KS is the fastest desktop CPU you can get right now. With that said, you can find us everywhere. LinkedIn.com/hothardware, Instagram.com/hothardware. I believe that's the name over there. YouTube/hothardware. We have a Patreon if you want to support us. That's really, a great way to keep the site going. We're one of the last independent tech publications on the web that's based in the US. We are everywhere, and obviously we try to stream as often as we can. We wish it was more, but we intend to be here Wednesday nights at 5:30 Eastern. Poke and prod us if you want us to do more of these things, because we want to build up the YouTube channel. And if you enjoyed this, please like and subscribe. And with that, I think we will bid you adieu.
Thanks for stopping by. Well said, buddy.